What is the difference between np.array and np.asarray? What is the difference between numpy's np.array and np.asarray? When should I use one rather than the other? They seem to generate identical output.
Since other questions are being redirected to this one which ask about a SAN array or other array creation routines, it's probably worth having a brief summary of what each of them does. The differences are mainly about when to return the input unchanged, as opposed to making a new array as a copy. Array offers a wide variety of options. Most of the other functions are thin wrappers around it, including flags to determine when to copy. A full explanation would take just as long as the docs, see array creation, but briefly, here are some examples. Assume A is an array, and M is a matrix, and they both have a type of float 32. np.array A and np.array M will copy both, because that's the default behavior. np.array A copy equals false, and np.array M copy equals false will copy M but not A, because M is not an array. np.array A copy equals false, subop equals true, and np.array M copy equals false, subop equals true will copy neither, because M is a matrix, which is a subclass of an array. np.array A type equals int, copy equals false, subop equals true will copy both, because the type is not compatible. Most of the other functions are thin wrappers around array that control when copying happens. Asarray, the input will be returned uncopied if it's a compatible array, copy equals false. SAN array, the input will be returned uncopied if it's a compatible array or subclass like matrix, copy equals false. Subop equals true. As contiguous array, the input will be returned uncopied if it's a compatible array in contiguous C order, copy equals false. Order equals C. As Fortran array, the input will be returned uncopied if it's a compatible array in contiguous Fortran order, copy equals false. Order equals F. Require, the input will be returned uncopied if it's compatible with the specified requirement string. Copy, the input is always copied. From it, the input is treated as an iterable, so, for example, you can construct an array from an iterator's elements, instead of an object array with the iterator, always copied. There are also convenience functions, like asarray _definite, same copying rules as asarray, but raises value error if there are any nan or int values, and constructors for subclasses like matrix or for special cases like record arrays, and of course the actual array constructor, which lets you create an array directly out of strides over a buffer.
The definition of asarray is: so it is like array, except it has fewer options, and copy equals false. Array has copy equals true by default. The main difference is that array, by default, will make a copy of the object, while asarray will not unless necessary.
The difference can be demonstrated by this example. Generate a matrix. Use numpy.array to modify A. Doesn't work because you are modifying a copy. Use numpy.asarray to modify A. It worked because you are modifying A itself.
The differences are mentioned quite clearly in the documentation of array and asarray. The differences lie in the argument list and hence the action of the function depending on those parameters. The function definitions are and The following arguments are those that may be passed to array and not asarray as mentioned in the documentation. Copy, bool, optional if true, default, then the object is copied. Otherwise, a copy will only be made if _array_ returns a copy, if object is a nested sequence, or if a copy is needed to satisfy any of the other requirements, dtype, order, etc. Subawk, bool, optional if true, then subclasses will be passed through, otherwise the returned array will be forced to be a base class array, default. Nun, int, optional specifies the minimum number of dimensions that the resulting array should have. Ones will be prepended to the shape as needed to meet this requirement.
If you want to see more,